Let's now do another large two-sample averages problem, and here it goes. The Energy Policy and Conservation Act of 1976 banned large oil companies from bidding jointly with one another in federal outer continental shelf lease sales. For bids on 2,870 tracts before the ban, the mean number of bids was 3.315 and the standard deviation was 3.043. In the post-ban period, 589 tracts attracted an average of 2.849 bids and the standard deviation was 2.262. Was there a significant decrease in the mean number of bids per tract from before the ban to after the ban? Use an alpha of 1%. As always, we're going to write down our data. Here we have two groups. We'll specify those groups. Group 1 we'll call before. It's the order that the data came in. So before the ban, we had a large sample of 2,870. The average from that group is 3.315 and the standard deviation is 3.043. Then group 2 will be the sample after the ban. N2 is 589. Average of 2.849 and standard deviation of 2.262. The question asked whether there had been a decrease. Alright, this is a time-dependent data set before and after, and so we can have a decrease. So the question is, has the average dropped over time? And we can see here that the earlier average is large and the later average is smaller, so in the sample there was a decrease. And we were asked to do this problem with an alpha of 1%. So decrease tells it's a one-tail test. It's a change in a particular direction. Our next step is to ask the question, which tail? As with all two-sample tests, we compare the two sample values. In this case, x bar 1 of 3.315 is compared to x bar 2 of 2.849, and clearly x bar 1 is greater than x bar 2. So, as always, there are two things we gain for that. It's an upper tail test for greater than, and the alternate includes that greater than sign. So instead of x bar 1 being greater than x bar 2, we want to know if the population equivalent is true. So the alternate mu1 greater than mu2. Alright, so now we're ready to write down both the hypotheses and short descriptions. So the alternate mu1 greater than mu2, the null mu1 less than or equal to mu2. As pointed out earlier, in the sample there's a decrease in the average from about 3.3 to 2.8. That which happens in the sample is translated to the alternate, so in the alternate describes a decrease. If you want to see it another way, mu1 is the average before the ban, mu2 is the average after the ban. The average after the ban is smaller than that before the ban, so that's a decrease. So the null is the complement of that, no decrease. as with all averages problems, from now on out, we check the degrees of freedom to find out if it's a large or small, and if it's a small, what degrees of freedom we need to use. In this case, both sample sizes are extremely large, so there's no question about the fact that the degrees of freedom are greater than 30. So we're going to use the Z to approximate this and do the large sample test. In two sample tests with averages, there is a difference between how we handle the calculations in a large and small sample test. So it makes some difference than in the one sample test. Alright, so we're going to do a Z-test. We draw the diagram, Z distribution. Remember, middle is always 0. It'll help you with the rest of the diagram. We are doing an upper tail test with an alpha of 1%. 1% in the upper tail. So going to our t-tables, looking for the appropriate critical Z value. Alright, Z, the last row, alpha of 1% is 0.01, so we have 2.326 for the critical value. Alright, so it's on the positive side, so it's a positive 2.326. Quick overview of the decision rule. If Z-calc is less than or equal to 2.326, alright, we're describing the acceptance region, which is where the alpha is not. So it's less than 2.326, it's possible there's no decrease. If we're where the alpha is greater than the positive 2.326, then it is likely there was a decrease. Okay, so let's write down our decision rule. If Z-calc is less than or equal to 2.326, null is possible, do not reject the null. Alright, it is possible there was no decrease. In other words, it's possible that the two sample averages are too close to tell if there is a difference or not. Alright, there was no decrease. Now for the rejection region, if Z-calc is greater than 2.326, the two sample values are sufficiently far enough apart so that we can reject the null as being unlikely, and in its place accept the alternate and say for the interpretation it is likely there was a decrease. Next step, calculations. Start off with the standard deviation, and this formula that we're using here is the standard deviation for the large sample test. It's an approximation of the real value, so it's the square root of S1 squared on N1 plus S2 squared on N2. So the data here is 3.043 squared divided by the sample size of 2870. plus 2.262 squared divided by the sample size of 589. That's the square root of that whole thing. Let's go to Excel and work this out now. This equals the square root of, let's put parentheses around the first, 3.043 squared divided by the sample size of 2870. Finish the parentheses on the first fractional ratio, plus an open second set of parentheses for the second one, 2.262 squared divided by the sample size 589, close parentheses for the second term and close parentheses for the square root. And the answer to 4 places is 0.1091. Alright, so 0.1091 for the standard deviation. Alright, and then we can do the z-calc, which tells us how many standard deviations the two sample averages are apart. So it's the sample difference minus the hypothesized difference divided by the standard deviation, this of x bar 1 minus x bar 2. Alright, the sample difference, 3.315 for x bar 1 minus 2.849 for x bar 2 minus the hypothesized difference, which is always 0, divided by the standard deviation, which we just worked out, 0.1091. And again, let's go to Excel and figure that out. So equals 3.315 minus 2.849 divided by the standard deviation, and that's 4.269. Scrolling up a little bit, 4.269 is clearly way out there in the upper tail. Okay, and we'll follow the second part of the decision rule to reject the null and say it's likely there was a decrease. So decision, since z-calc is 4.269, which is greater than the 2.326, the critical value. Those two sample averages are very far apart, so we can reject the null, which says that they're not far apart, or there's been an increase. In its place, we'll accept the alternate, and interpretation is likely. There was a decrease. And that's the end of that problem.